Welcome to Altair Engineering Training and Support. I am Apur Bapat, working with Altair Engineering as Hyperview Specialist FEA. I welcome you all in SAE Baja 2016 online training sessions. So the topics which I am going to cover in the complete 5-day training sessions are as follows. Today, that is the day 1, I am going to show you the 2D meshing, geometry editing and analysis on the 2D meshing of the roll cage. Tomorrow, that is on day 2, we will see the torsional rigidity and bending stiffness calculations on the roll cage, the concept and theory of FEA and CAE. On day 3, we will see how to perform dynamic crash analysis on roll cage. Then on day 4, you will see the knuckle, hub and the different components, 3D components, how to do meshing and analysis of those. On day 5, we will see the suspension analysis using MVD. Before starting, I just like to mention few points. The biggest question arises is why we can do 1D meshing on roll cage, 2D meshing on roll cage or 3D meshing on roll cage. So these are the some comparisons or some points to decide what type of meshing you should do. 1D, 2D, 3D are all, it's like more accurate or less accurate. It is not like it is correct or wrong. In CAE or FEA, it's nothing like it is correct or wrong. It is like accuracy changes. If you choose wrong input, the output accuracy will change. So 1D is less accurate. Why? The level of assumption is more. As 1D element didn't capture the geometry properly, calculations on the joints are not captured. So the element type here is beam element. Input required is the cross section of the pipes. Output received is axial stresses on the beam. Then 1D element are stiffer, so application of force are higher, which may lead to over design. You can take the average element size as 3 mm to capture the geometry properly. If I talk about 2D meshing, it is more accurate and preferable. So the level of assumption is very less. It captures the geometry properly, give results on joint. Chord or tria or mixed are the type of elements. Then input required here is thickness of the pipe because we do 2D meshing at the mid surface. And output received is von Mises stresses and displacement on 2D elements. 2D chord elements are appropriate stiffness, so results will be more accurate. We can take the average element size as 4 or 5 mm to capture the geometry properly. 3D meshing is not required, as the definition of 3D meshing or 3D element state that all the 3 dimensions have to be comparable to do 3D meshing. But for the roll cage, all the 3 dimensions are not comparable. The length of the pipe is very big as compared to the cross section or the thickness of the pipe. So doing 3D will be very less accurate. So level of assumption is average. It captures the geometry as it creates 3D elements across the pipes. It also gives the results at joint. Most preferable elements, or most of the time people use tetra elements. No additional input required because tetra element itself is in 3 dimensions. We get output as von Mises stresses and displacement on the 3D elements. 3D tetra elements are more stiffer, so the results are not up to the mark. Then average element size is 3 to 5 to capture the geometry properly. So that's why doing 2D meshing is advisable. It is not like you should do it, it is advisable to get a more accurate results. CA is all about getting more accurate, less accurate results. So how you give the inputs, the similar way you get the outputs. So getting more accurate outputs is our ultimate aim. Then sometimes I get really funny answers when I try to understand what student has done in the roll cage. So that's why I keep this slide that what is advisable. So 1D and 3D analysis is not much accurate as compared to 2D analysis. Material properties required for CAE static analysis are Young modulus, Poisson's ratio, density, and for dynamic crash analysis, hardening coefficient, yield stress, ultimate stress are required in addition to the above. For static front, side, rear, it is not accurate to compare as compared to dynamic front, side and rear, because the front impact, side impact and rear impact are going to happen when the case is dynamic. So getting the results of static will be less accurate as compared to dynamic results. So now for front impact analysis, static front impact analysis, the force applied on the front pipes and constrained at the suspension joints giving proper degrees of freedom. Advisable force for front impact can be 3 to 6 G considering the Baja roll cage only. For static side impact analysis, force applied on the side members and constrained at the bottom suspension joint, constraining all degrees of freedom. Advisable force for side impact can be 2G to 5G. Rear impact analysis, force, this is advisable. It is not like that you have to use these values. It is good to use these values. If you have any calculation to justify any different values, you can use the different values also. Rear impact analysis, the force applied on the rear members and constrained at the suspension joints, constraining appropriate degrees of freedom. Advisable force for rear impact can be 3G to 6G. Torsional analysis, force applied on the opposite direction on the suspension joints, either on front or on rear, and accordingly apply the constraint. Advisable force for torsional is 2 to 4G. For bump, we apply the force on the front or rear suspension joints and constrains the other suspension joint. Advisable force can be 3 to 5G. For rollover, angular forces applied on the top side of pipes, that is, as you can see here at the top end of the roll cage, and constrain the suspension joints. Advisable force for rollover is 1.5 to 2G. The above forces are for static analysis, which is based on assumptions via time of impact and material on which the impact will happen. But if the team perform dynamic analysis, then the assumption made in static will be addressed properly, which gives more accurate results. So that's why dynamic analysis gives you more accurate results. For all static analysis, factor of safety can be in a range of 1.3 to 3. 1.2 to 3, anything more than that may lead to over-design. It is not like that, it is always lead you to over-design. It may lead you to over-design. Deformation in terms of displacement has to be within the permissible limit. What is the permissible limit is your driver has to be safe in all the cases of impact. That is the permissible limit. So I cannot say the 5 mm displacement is okay, because in front impact, if we assume the 5 mm displacement is good or if preferable, and you have the driver's foot is below that, so it is not advisable. So it depends on your design. So you have to see the permissible limit of the deformation of roll cage, and after deformation that portion of the roll cage should not hit a driver in any case of the impact. So that is the permissible limit. Now we will see how to perform what I have shown you. This is the images which I am going to show you practically also. So this is the case of front impact, where we constrain the suspension joints and apply the forces. Similarly, side impact, similarly rollover, then torsional, then bump. So these are the different cases which I am going to show you today. So let's start with Hypermesh version 30. I'll quickly explain you the GUI. The first window which you are able to see here is the user profile. User profile means selecting for the proper solver. So whatever solver you want, see in a CAE there are three steps. One is pre-processing, solver and post-processing. Right now I am doing the pre-processing part. Once my pre-processing is done, that is creating a solver deck, a file ready to solve it. Then I will solve it using some other solvers. Today I am going to use OptiStruct, which is a solver for it comes in Altair HyperWorks. Then the post-processing part, that is the results visualization, that I will do in Hyperview. So if you have any other solvers, you can create a mesh in Hypermesh, create a solver deck in Hypermesh and solve it there, and you can bring the result file in Hyperview also. But that is very tedious job. It takes a lot of experience to do it. So my suggestion is completely follow the steps from Hypermesh to OptiStruct to Hyperview to get the results faster. So I will select the user profile as OptiStruct because I want to solve this file using OptiStruct solver. So once I select the user profile, it appropriately creates some macros and templates so that I can provide the inputs required and get the outputs required. So the first point is, let's bring the geometry. This is my roll cage geometry. Before going further on this geometry, I want to show you something other, one more thing. This I have one more geometry. Here you can see I have a line data. You can see here I have a line data. So if I mask the solids, so you can see I have a line data. So I can only do 1D meshing on this because it's a line. But if I want to do 2D meshing, I need a data like this, a surface data. So sometimes what people do, they create a surface data on a CAD model, they import it in Hypermesh, they try to solve it on 1D. So for 1D you need a center line data of the roll cage, for 2D you need a surface line data of the roll cage. There are two different type of geometries required for two different types of analysis. So that's what I want to clear, first point. Then the second point, you can see here, this is my surface data, I don't have any line data here. So if I mask a pipe, you can see it will have an inner surface and an outer surface. So now if I create a 2D meshing here at the outer surface and at the inner surface and give the thickness of same of this thickness, so I have two elements, one at the top, one at the bottom, and it gives the thickness half up, half down. So I will have double the thickness of actual geometry. That's why I create a mid surface here and do the meshing at the mid surface. I will show you what I am saying. You can see this is the mid surface. So in 2D, if you do meshing, then the element's thickness will go half up, half down. Similarly, half up, half down. So actual thickness, if you use these two surfaces, will get doubled. And my actual geometry and my geometry created because of the elements and nodes are too different. That I don't want that. I want the same geometry from elements and nodes and the same geometry from these surfaces. So that's why I create a mid surface, do the meshing on here. So when I give a thickness on these centered elements, then half the thickness go up, half the thickness go down. So I will capture the geometry properly. That is my aim of doing the meshing. So that this process I am going to show you. Another thing, what generally people don't do is they in the software they just bring this file, or they can have a direct mid surface geometry from the CAD. They bring the file, mesh it, apply the force, constraint and solve it. But they don't check whether all the pipes are properly connected or not. So if the pipes, all the pipes are not properly connected, then the results may vary. It is not about getting the results in any cost. It is all about, CA is all about getting more accurate results. So for getting a more accurate result, you have to follow a process which is accurate. So while you import a geometry, you have to see whether all the pipes are properly connected or not. If it's not, you have to connect it and then do the meshing. So in most of the softwares or most of the teams I have seen, they haven't done any geometry editing, any pipe connection, any mid surface. They just did the meshing and solve it. So that is not correct, because if the connection from here to here is not there, so whatever the force and constraint we apply, it will not travel throughout the roll cage. That's why I want a proper connection. So I will check it today. I'll show you how to do it and then we will go further. So let's take a joint, any one joint I will show you. You have to follow the same process for the entire geometry. So let's take this pipe. So first of all, I want to create a mid surface of this, and then I will join those mid surface to have a singular pipe. So to create a mid surface, I'll go to geometry, mid surface, pick first surface, pick another surface, and pick the other surface and say extract. Similarly, this surface and this surface extract. So it creates a mid surface. It's another component for mid surface. Similarly, for this pipe, for all the pipes I want to create a mid surface. So if I turn off this, you can see I have a mid surface geometry, but this geometry has red edges which is not connected. So I will now try to connect this. So to connect it, first thing is press F11 from your keyboard to get into edge edit panels. I will toggle this surface. Toggle means join these edges. Red edges means there is a gap between these two edges. So I will try to join it. So it has to be green, where green means the edges shares the two surface. That is a shared edge. So all the edges has to be shared. I don't want any edge to be red apart from the edge at the corner of the pipe. So in my roll cage, for entire roll cage, all the edges have to be red in color. So now I have to trim this. So for trim, I will go to Shift F9 or Geometry page, Surface Edit. I'll use the trim with surface panel plane. I will pick this surface, but you can see here the surface also here comes, the edges also here comes the red. So again F11, toggle, toggle, here also toggle and toggle. So this is done. Then surface edit or shift F9, this surface trim with these two surface. So now you can see this also comes green. Now if I turn it on line data, you can see everything is green here. So it is connected. That's what I want. So all the pipes have to be connected properly. In this way, you have to do it for the entire geometry. Create a mid surface on the entire geometry. Join all the mid surfaces. So I have a file for that in which I have already done the mid surface and connection, everything I have already done. You can see if I make it in the line mode, all the pipes I have, there is no red edges. So all the pipes are properly connected. You can see here in green color, there is no red edges. So the blue dotted lines means these are suppressed. So I can turn on these anytime I want. So suppressed edges can be turned on anytime I want to get the geometry back. So that I can do. But I don't want red edges. I want all the red edges to be converted into green ones so that my geometry is properly connected. I can only check the geometry is connected or not after the meshing, but I can also check a little portion of geometry connected or not at the geometry by seeing it with the red edges or not. So you have to make sure all the edges of the geometry is red. So I'm just showing how to convert the blue edges to the green one. That's it. If I check the geometry here, you can see it is not connected. So there is a gap. So this gap is because of something. So I don't want this gap to be filled out. Similarly, you might have a geometry where you have a pipe extending here or a pipe extending here that you don't want to merge. So the pipes you don't want to merge, keep that red as it is. You don't need to merge all the pipes. So you have to create a geometry which is properly connected. Now as my geometry is created and edited properly, now I will move to a next step, that is meshing or creating elements and nodes. So as I have a 2D surface, so I will do 2D meshing. So for 2D meshing, I will go to 2D page. On 2D page, I will click on auto mesh panel, which is on 4th column, 3rd row. I will pick the surfaces, that is I will select all surfaces. I will take the average element size. This is the average element size as 5. Element size or type as mixed. Element to surface component. I will take first order of elements and click on mesh. Once I click on mesh, it is automatically generate the 2D meshing. You can see here it has generated, at the bottom you can see it has generated 1,38,000 elements and one surface is filled. So it has also said that on which surface it is not able to create the meshing and which surface is failed. That I will check later on. So I will click return, turn off this. So I have the elements. So this icon is for viewing the surfaces or edges, and this icon is for viewing the elements. So I'll turn off this, and I have a check to see all the elements are connected or not. So if these elements are not connected, it's okay, but other than that all the elements have to be connected. So that check is through Shift F3. So press Shift F3 from your keyboard, drop down, select elements, select all the elements, enter the tolerance value as 0.1, that is the gap between two nodes. Click on preview equivalence. It will give you how many nodes are not connected, and click on find edges. So once you click on find edges, it will show you the area where the elements are not connected. So you can see this is one area where the elements are not connected. This is perfectly fine because the elements are not connected here. But the other problem is this. I find one space where my meshing said one area failed to do meshing is this. Here also I find a gap. As I already told you, I don't want any gap on my roll cage. I want every element to be connected. So I will see why this gap comes. So you can see there is a huge geometry issue here. That's why this issue comes. So I'll try to solve this geometry issue. Now I will see if it's generated the meshing or not. So it is creating some problem here. So I will try to address it properly. So I have removed the surface here because of which it is creating the problem, and I will try to create a new surface. For creating a new surface, I have n number of options, but I'll use one of them. So I'll go to F11, use the filler surface option and try to fill this surface. So now this surface is filled and is connected properly. So again I will do the meshing, element solve. First I will delete the existing meshing. F12 is the shortcut for 2D auto mesh. Select all the surfaces. Again I will do the meshing. So last time the problem comes here. He gives me the error. But this time there is no error, as I have already cleared that error which was coming. So I will delete this edge. Again I will check for the mesh connectivity. So again Shift F3, select all the elements, preview equivalence and find edges. So now I find only these two edges, which is absolutely correct. Other than that, I am not able to find a single edge or single free element anywhere from this. So these nodes are free. That is absolutely correct. As per my requirement, these nodes have to be free. But other than that, everything is connected. That's what I want to check, that all the elements are connected or not. So once this check is done, the another check before solving the file is the elements quality. So I will press F10 for this to see the elements quality. So the first quality is the warpage, that is the out of plane angle, one of the node moves out of the plane of that element. It only comes in for the chord elements. It will not come for the tria, because in tria we have 3 nodes, and to define a plane we need 3 nodes. But in chord we have 4 nodes. So with the help of 3 nodes it defines a plane, and the 4 nodes move out of that plane. So I will see how many elements are failing. So I will take a bigger data for as 30 degrees and see. So you can see some of the elements are failing here. So you can see why this is failing. So this is a quad. Some of the nodes move out of the plane. If I take this as the plane, 1, 2, 3, this nodes move out of it. If I show you individually, you can see that. So you can see one of the nodes moved out of the plane. That's why it's coming as warpage. So to solve the warpage issues, I have so many elements where the warpage issue is coming. To solve the warpage issue, I'll again go to FL. This time instead of surface, I will select elements. Select all the elements, say tria, and mesh it. So as I already told you, the warpage will not come in tria. So I will create all the elements, or I will convert all the chord elements to trias. So my warpage issue gets solved. Now I don't have any things in warpage. Now the next check is Jacobian. So all the elements are passing in Jacobian, which is having more than 0.3. Minimum angle tria. Some of the elements are failing in minimum angle, that is 7. I will check that. For checking it, I will click on save failed, go to mask or press F5 from the keyboard, click on the elements, click on retrieve. So whatever elements I have saved there, it will retrieve those elements. At the bottom you can see it is retrieved 7 elements. I will click on mask and reverse. So it will show me those elements which is failing in the minimum angle criteria. So I will press shift F2, click on nodes displayed, and add those nodes. So I can easily pick which are the elements are failing in the minimum angle criteria. So you can see here one element is failing at the minimum angle. So I just want to increase this distance by, you can say, 0.5 or 1.5. Similarly here also, this is coming because of the geometry. My geometry was not proper, that's why this type of error is coming. So this is solved. Similarly, this is solved. So in the same way, you have to solve all these errors so that your elements will be proper. Proper elements give you proper results. I can remesh this also. I'll put as mixed to remesh. So I am showing you both the options. You can choose as per your requirement. So you can see here the meshing was not that proper. So I will remesh the entire domain. So my meshing is done. So now this is the one way increasing the length. I will show you the other way to solve this issue. The other way is again minimum angle, 3 elements are failing, so save failed, mask, elements, retrieve, mask, reverse, shift F2, add the nodes, Then shift F5 to find the attached elements. So these are the attached elements to the element which is failing, and simply remesh it. Return. I will again check minimum angle. Now 0 elements are failing. So in this way you can solve these problems. So this is minimum angle. You can see at the bottom 0 elements are failing. Similarly, maximum angle 152 can be taken. For minimum angle quad 21 is good. 167 is okay. We can go further with it. Best values is this. So getting into best is always better, but we can go for okay also. Now my meshing and elements quality, connections, everything is done. Now I will go further. That is applying the material properties, updating the component, creating loads and boundary conditions, applying load step, that is defining the type of analysis, and solving the file. So this is a step-by-step process. So first step is to create the material. To create the material, I'll click on material icon where my mouse pointer is. You can see the material icon. Enter the material name as steel. Define a color. Select the type as isotropic. Card image as matte 1. Click on create edit. Then enter the values of E, new and row. Then click return. Again click return. So in the model browser you can see my material is created. Now I will create a property. So to create a property, there is an icon on the right hand side of property. Click on create radio button. Enter the property name as roll cage. Define a color. Select the type of the elements which you have done. As I have done 2D meshing, so I will select the type as 2D. Card image as P shell. Material as steel. Click on create edit. Here we need to enter the thickness. So I will enter the thickness as 2. You have to enter the thickness, whatever pipe thickness you are having. Then again return. Now I will assign this property. I have assigned material to property. Now I will assign the property to component. So on the left hand side of material icon you will find component icon. I have already one component where my elements or nodes are there. So I will just update that component with proper property. So I will go to update radio button. Click on comps, that is component. Select the component which I already have. Instead of no property, I will toggle it to property. Click on the property and select the property which I have created earlier. So once I select the property, you can see here it is selected P shell and matte 1 card images, that is the thickness, and E new row value. Then click on update. So now what I was trying to tell you, that it creates the thickness halfway down, halfway up. So that thing I will show you now. So first of all, mask this, then elements, mask, mask, reverse, then surface, mask, reverse. So as I already told you, the element should represent exactly how the geometry is representing. So if I make it in a 3D representation, you can see it has taken the thickness half up, half down. So it will become exactly as per my pipes. But if I have a two meshing, so it will give me the double thickness, which is more stiffer, which is not correct. Okay, so that's why I want to do meshing on the mid surface and give the thickness to divide my geometry properly in elements and nodes. So this is done now. Now my material property and component updation is done. So I'll move to the next step, that is creating loads and constraints. So this is a process to do it. This process you have to follow to do it on your roll gauge. Whatever forces I am going to take here is not correct. I am going to show you the process. Why I am not going to take the correct? Because whatever I show you here, most of the students, let me correct myself, almost all the students exactly select that particular force. So that's why the forces I am going to select here is absolutely wrong. Similarly with the roll gauge, this roll gauge, please don't try to make a similar roll gauge. This roll gauge is extremely heavy and it will not sustain any loading condition. It will fail the moment even a bird sits on it. So please don't try to copy this roll gauge, don't try to copy the forces which I am going to show. I am going to show you the process how to solve front side rear rollover bump torsional analysis. The same process you have to follow providing your inputs. The process will be same but inputs have to be different. So I will start with applying the loading conditions. So first is front impact. So I will create a force. So to create a force, I will create a load collector for force. So I will create a load collector. There is an icon on the right hand side of property icon, that is load collector. I will enter the load collector name, load call name as force. Give a color to it and say create. Then I will click on return. Go to analysis page, forces, that is on fourth column, fourth row. Sorry, that is on second column, fourth row. I will select the nodes where I want to apply the forces. So let's assume I am applying the forces at the front side of my roll cage. So shift and drag it to select the nodes. So I have selected the frontal member nodes. My roll cage direction, I will see in which direction my roll cage is, like this if I put it. So you can see my roll cage is in negative Z direction. So the force which I am going to apply will be positive Z. I am applying 10. If I save this, so I have selected 1404 nodes. So 1404 multiplied by 10. So I am applying 14,040 Newton of force. I don't know how I come up to this value. So either this is 3G, 4G, whatever. But if I consider my weight of the car or the weight of the entire ATV to be 300 or say 200. So divided by 200 divided by 10. So I am applying 7.2 G, which is way higher. That's why I initially mentioned that don't apply the force which I am applying here. You have to do the calculation as per your requirement and then apply the force. Say for example, you have selected X number of nodes and you have decided to apply 4G. So 4 multiplied by weight of the car multiplied by 10 is the total Newton of force you want to apply for front impact. Let's assume the number of nodes you have selected is 19328. So here the magnitude you have to enter as 5.18. So the entire front impact force will be 10,000 which you have calculated. So the force will be acting on each and every node. So the number of nodes multiplied by this force will be total amount of force. You don't have to apply total amount of force on each and every node. And then click on create. So once you click on create, you can see it has created the arrows. I will increase the size of those arrows so it will be more visible. So you can see here, I have applied a force at the front side. I can increase the size to big so it is more visible. You can see. Now similarly I will give a reaction force to this force, that is the constraints. So I will click return. To apply constraints I will again go to load collector icon. Apply the load collector as SPC, that is single point constraint. Define a color to it. Click on create. Go to analysis page, constraints, and pick the suspension mounting points. So let's assume my suspension is mounting here. So suspension mounting points matlab means where your suspension is going to mount on the roll cage. So the point where the suspension is going to mount, you have to apply the constraints there, as the reaction to this force will come from the suspension mountings. So that's why I am applying the constraints on suspension mounting points. So if your suspension are at the joints, apply the constraint at the joints. If your suspension are at the some distance, calculate the distance and apply the constraints there. So create. Similarly rear. I am again repeating one thing, the suspension mounting points which I am taking is absolutely wrong. Nobody can mount a suspension like this. So don't try to copy this like this I have taken, so you also take there. You have to exactly apply the constraint where the suspension mounting point is. So create. So now I have done with my suspension mounting points, constraining them and applying the force. So the next point is I will create a load step to define the type of analysis. I will select the type of analysis as linear static. Name of the analysis as front impact. Check the box in front of SPC and load. Select SPC as SPC, load as force and click on create. So my complete process is done. So now I will save this file as front impact Then I will go to analysis, OptiStruct to solve this file. Export option I will select as all. Run option I will select as analysis. Memory option I will put here as 4000 MB. So it will run faster instead of 320. I will give the maximum RAM of my system and click on OptiStruct. So a solver window started. It will take some time to get the results. So there is some elements quality check error as you can see here. So some of the elements are failing that I want to clear it. That's why I didn't clear all the elements. So I will check this element. Press F10 or first F5 element by ID. So enter that ID. So it has selected that entity, mass, reverse. I will turn off the load step, load collectors, shift F2, select that element and see why it is failing. You can see that it is having the warpage very high. So I will try to solve it. So if I click here, you can see its warpage is very high. So I will try to solve this warpage issue by just simply element tria mesh return. So this is done. So F10 warpage, one element again it's failing, save failed. F5 elements retrieve, mask and reverse, shift F2, add. So this element is failing in warpage. So F12, so save the file, octistruct, yes. Sometimes people say that check on the box of check elements on and off so that it will not check the elements quality, but I don't suggest it. If you want to do that, you can do it, but I suggest you to clear all the elements quality and then try to solve it, because element quality plays a very important role in analysis. If the quality of element is poor, the interpolation function is poor, which will lead you to a poor results. So always try to make a better elements, and whether it will take time or not, that doesn't matter. Your results have to be appropriate and more accurate. So now I have solved those two elements and I got the results. Analysis completed. So I'll click on the results. To open another window of Hyperview to view the results of my analysis. So I'll click on contour and apply. So this is the displacement which is coming, and stresses is, this is what the stresses is coming. So if I see the animation of front impact, so because of front impact, the maximum failure can happen here, and that's what my results are like. So maximum failures at joint, this is what my software is saying. This is the maximum failure location. This is what my software is saying. It can fail here also because it's buckling. So you have to see the results and judge that what are the critical areas because of front impact. So in this way you have to proceed further. So now I'll close this, move to the next one. So for the next case, I will delete the existing and I will create multiple load cases and solve all those multiple load cases at a single file, on a single file, and get different results. I'll show you how you can do that. So I will have a side impact force, then rear impact force, torsional force, bump force, rollover force. So now I have side, rear, torsional, bump, rollover forces. Similarly, I will create constraints for these. So side impact SPC, rear impact SPC, torsional SPC, bump SPC, rollover SPC. So I have created the forces and constraints load collector. Now I will apply these. So to apply it, first I will have rear impact force. So I will click here or right click on this and say make current. So side impact force, make current, analysis forces. I will select the nodes of the side member. Similarly, I will see the direction which is positive x-axis. So I will select x-axis and say create. So I have a force for side impact and SPC make current. So analysis constraint. Similarly, for side impact, I will select the suspension mounting points at the bottom only. Only the bottom suspension mounting points I will select, front and bottom, front and rear, bottom suspension mounting points, and say create. Similarly, once this is done, I will create a load step, side impact, SPC as side impact, load as side impact, and create. So I have a load step for side impact. So I turn off this, rear impact, make current, analysis, forces, select the nodes, for the rear impact. The direction now you can see for rear impact is negative Z direction. So minus 10 in Z axis, create. So the force direction you can see is negative Z. Now rear impact, make current, analysis constraints, suspension mounting points, intentionally I am choosing different suspension mounting points for different analysis, so that if you want to copy, you cannot do that. So again I am saying you have to pick suspension mounting points. I am not saying pick these points. Create, return, load step, rear impact SPC, rear impact force, rear impact force and rear impact SPC, create. So 2 and 7 off. Then torsional. So make this as current, analysis forces. For torsional, force on the suspension mounting points in one direction, say 10 in y axis, create, and similar force in opposite direction So these nodes, these nodes, and these nodes, but in opposite direction, say create. So you can see here, and if you are solving it for front torsional, then this is the case. So for front torsional, I will constrain the rear suspension mounting points, and for rear torsional, I will constrain the front suspension mounting points. Create. Then load step, torsional, SPC, torsional SPC, load, torsional force, create. Turn off this, bump, make current, analysis, forces. Now I will solve this for rear bump. So picking these nodes, in y-axis positive, create. You can do rear bump and front bump both. It depends on you. So rear bump, SPC, so front constraint suspension mounting points. Similarly, pick this, create, return. So bump done. Now come for rollover. In rollover, we need to apply a force which is angular. But in this, here, if I come here, I cannot apply a force angular way. I have a direction to specify and I have to apply the force there itself. So what I'll do now is I will create another system and rotate that system and apply the force in angular way. So how I can do that, I will show you. So analysis page, systems. Then I want to create a system, say for example, I want to exactly similar system as the global coordinate. I will create a local coordinate system right now, but with a reference of so this is the points I have. So shift F2, I will have a point add here, shift F4, I will duplicate and translate the point in Z direction to 10. Then I will translate it to Y direction, duplicate it. So this is the node I want in the system. Origin is this, x-axis, xy plane, and create. So I have a system here, you can see this is my local coordinate system. I have a local coordinate system for this geometry. Now I will rotate this local coordinate system. So I will go to analysis tools, rotate, system, pick this system, rotate x-axis at this point by an angle of 45 degree. So the x-axis, it has rotated to 45 degrees. That's what I want to apply the angle. So I will go to analysis, make the rollover force, make current, analysis, forces. Instead of global, I will pick local coordinate system, that is this. I will pick y-axis, negative direction, and apply the forces at this points where my first impact will happen if my ATV rolls like this. So first point of contact, this, or maybe this one. So I will create here, click on create. So now you can see I have an angular forces. My forces is angular now. That's what I want. So I will have SPC as make current. Go to analysis, constraints. Again, we have to constrain the suspension mounting points for this too. Create, return, load step, rollover. SPC, rollover, force, rollover, create. I haven't created a bump load steps. I will create a bump. SPC, bump, load, bump, create. So now I have 5 load steps with 5 load collectors. So I will save this file and solve it. So now I will solve one single file and get 5 different results. That's what I want. I want the results of these 5 or 6 different cases. So either you can have 6 different files and solve it separately and get the results separately, or you can have a one single file, apply all 6 different cases on that single file, solve it once, and now I'll show you how you can get 6 different cases. That is the main objective of it. So it will take some time to solve. Now you can see I got an analysis completed message. So I will click on results. So this is my roll gauge. I will turn on the system. Here you can see subcase 2, that is side impact. So whatever result I will see is for side impact. So displacement for side impact. If I turn on the animation, and stresses for side impact. Similarly, if I keep changing here, rear impact, torsional, rollover, bump, stresses, displacement, bump, side impact, rear impact, torsional, rollover, and bump. So I can have a single file and get the results of all and see them individually also. So in this way I can get all the results and save the files accordingly. So thank you very much for attending this webinar. In this way I have ended this first day session. Tomorrow I am going to discuss about the torsional stiffness, bending, torsional rigidity, bending stiffness, and the concepts behind CAE and FEA. If you have any queries, feel free to contact us at edu-support@india.altair.com. Thank you very much.